A satellite orbiting Earth 340 kilometers above the surface makes one complete revolution every 90 minutes. The radius of Earth is approximately 6,370 kilometers. In Part A, calculate the angular speed of the satellite. Express your answer as an exact value in radians per second. When the satellite revolves once around Earth, it travels an angle of 2 pi radians. The time for one revolution is 90 minutes, or 5,400 seconds. We get this by multiplying 90 minutes by 60 seconds per minute. Now we'll use the formula for angular speed. Plug in 2 pi for the change in angle and 5,400 seconds for the change in time. This reduces to pi over 2,700 radians per second, which is our exact value answer for the angular speed. Now we'll move on to Part B. How many kilometers does the satellite travel in 1 minute? Round your answer to the nearest hundredth of a kilometer. In Part A, we found the angular speed of the satellite, pi over 2,700 radians per second. In 1 second, the satellite travels pi over 2,700 radians. In 60 seconds, 1 minute, the satellite travels 60 times pi over 2,700 radians, or pi over 45 radians when reduced. If the radius of the Earth is 6,370 kilometers, and the distance from the surface to the satellite is 340 kilometers, then the distance from the center of the Earth to the satellite is 6,370 kilometers plus 340 kilometers equals 6,710 kilometers. Now we'll use the arc length formula. Plug in 6,710 kilometers for r and pi over 45 radians for theta. In 1 minute, the satellite travels approximately 468.45 kilometers.